Swayam Prabha. Digital India. Educated India.
Good morning everyone. So today we are going to continue our lecture on the tutorial classes on compaction after index properties of soils. Now we are going to use the index properties of soils, the previous lecture that we have attended, on the previous tutorial class that we have attended on this compaction. So the first question that I am going to discuss on compaction is basically on a modified Proctor test. So the question states that modified Proctor test yielded the following values of water content and densities of clay gravel. Now the values of water content are given as 3, 4.45, 5.85, 6.95, 8.05, 9.46, 9.90, and the corresponding gamma D by gamma W is given as 1.94, 2.01, 2.06, 2.09, 2.08, 2.06 and 2.05. Now it is asked in the question to draw the Proctor compaction curve and calculate the degree of saturation, that is SR, corresponding to optimum condition. Assuming that the specific gravity of solids, that is GS, is equal to 2.65. It is also asked that calculate the percentage of air for a given porosity N and degree of saturation SR. So we are going to first do the first question, that is drawing the Proctor compaction curve. Now drawing the Proctor compaction curve, we will just plot them directly on the graph paper. So basically with the dry density, so basically the graph looks somewhat like this. Now we have water content as the abscissa and dry density or gamma D as the ordinate. Now now basically the graphs look somewhat like this, as we have already seen in the lectures. So this point, the topmost point, corresponds to the OMC, or the optimal moisture content, and this also corresponds to the gamma D max, the maximum dry density. So basically it is find out that the gamma D by gamma W is actually equivalent to 2.09, and the optimum moisture content, or the OMC, is found out to be 7.5%. So the first question, so after the first question we now move to the degree of saturation corresponding to the optimum condition. Now assuming GS equal to 2.65, now how do you do that? Now we all know that Wg equal to Se, Wgs. Now we can write Gs in the form of gamma S by gamma W, because we know that Gs is the specific gravity of soil solids. So we can write W into gamma S by gamma W is equal to S into E. From here we know that S is equal to W by E into gamma S by gamma W, or SR equal to W by E into gamma S by gamma W. Again, gamma S generally responds to the soil solids. So if it is a soil solids, then basically it generally corresponds to the dry density. So gamma D is equal to gamma S by 1 plus E. So from here we can get that, E is equal to gamma S by gamma D minus 1. Now how do we get this relation gamma D equal to gamma S by 1 plus E? This is from the general relation that gamma D is equal to G by 1 plus E. So basically into gamma W. So basically we write that gamma D is equal to gamma S by gamma W into gamma W by 1 plus E. So gamma D is equal to gamma S by 1 plus E. So from here we obtain that E is equal to gamma S by gamma D minus 1. So we can also write 1 by E is equal to gamma D by gamma S minus gamma D. So at optimum condition we are asked to find out that what is the degree of saturation is. So at optimum condition, SR optimum is equal to W optimum into gamma S by gamma W into gamma D optimum by gamma S minus gamma D optimum. Now if you put all the values, this is 7.5%, because we have already seen that the W optimum is 7.5%, into gamma S by gamma W, which is nothing but the specific gravity of soil solids, into gamma D optimum, which we have found out to be 2.09. So 2.09 by gamma S, which is 2.65 minus 2.09. Actually we divided by gamma S, gamma D by gamma S, sorry, we divide by gamma W in all these cases. So this came down to be gamma D optimum by gamma W divided by GS minus gamma D optimum by gamma W, which is nothing but 2.09 by 2.65 minus 2.09. Now the SR optimum comes out to be 74% in this case. So the percent, so basically the degree of saturation corresponding to optimum condition comes out to be 74%. Now moving to the third question. The third question states that calculate the percentage of air for a given porosity N and degree of saturation SR. Now how are you going to solve this? In this case, let us first consider that the soil mass consists of air, water and soil solids. Now the percentage of air is assumed to be A, while the percentage of water is assumed to be N into SR, and this is assumed to be 1 minus N. So the entire soil volume is assumed to be 1. So basically the volume of soil is equivalent to 1, while if we remember the definition of porosity, then it is equivalent to VB by V, where VB is the volume of the voids and V is the total volume of the soil. So the volume of voids, which equals the volume of air plus volume of water, that means this part actually equals N, or the porosity of the soil, because the total volume of the soil is 1. So from there we can find out what is the volume of air, that is equivalent to N minus VW. Now we also know that the degree of saturation can be written as the volume of water divided by volume of voids, that is what is the degree of saturation is. So the volume of water can be written as SR into VV, and we have already said that VV is equivalent to N, so SR into N. So N minus SR into N, so this is equivalent to 1 minus SR into N. So the volume of air is found out to be 1 minus SR into N. Now the following relationships exist, that the volume of air can be written as 1 minus volume of grains, means volume of soil solids, minus volume of water. Now volume of soil grains or soil solids, whatever you may call, is equivalent to weight of soil grains by gamma s, because the density is equivalent to weight, because the specific unit weight is actually equivalent to weight by volume. So the volume of soil solids will be equivalent to the weight of grains, or which basically is the soil solids, divided by the density of the soil, unit weight of the soil solids. This is the unit weight of the soil solids. Now the weight of the soil solids or the weight of the soil grains is again can be written in the form of gamma d by gamma s, because gamma d is the dry density of the soil mass, which basically consists of only the soil grains and nothing else except air. Similarly, the volume of water can be written as weight of water by gamma w. Here the same thing applies, the unit weight of water is equivalent to the weight by volume. So basically the gamma volume of water is equal to weight by the unit weight of water. So now basically what we will do is that we will multiply the top and the bottom by weight of grains. So we will multiply at the top with weight of grains, and we will multiply the bottom by weight of grains. So we all know that water content of a soil can be written as weight of water by weight of grains, or the weight of the soil solids. The weight of the soil solids and the grains are same. So from this relation we can write WW by WS into WS by gamma W. Now this is nothing but the water content of the soil into WS by gamma W. Now WS, or the weight of the soil solids, as I have said previously, is nothing, is again gamma D by gamma W, because the soil solids only is present in the is basically the soil solids, because we consider the unit volume, the volume of the soil solid to be 1, and if the volume of the soil solid is 1, then gamma D can be written as weight of soil solids by volume of the entire mass. So, weight of solid solids, if you consider it to be Ws, the volume of the entire mass we have considered it to be 1. So, Ws by 1 is equal to gamma d. So, Ws is equal to gamma d. So, that is why we have everywhere replaced the weight of the soil grains by gamma d. So, the volume of water we found out to be is equivalent to W into gamma d by gamma W. Now, we have already found out that the volume of water is also equivalent to 1 minus SR into N. So, we can write A is equal to W into we have already found out that the volume of water, we have already found out that the volume of air is actually equivalent to, the volume of air is actually equivalent to 1 minus SR into N. Now, we are going to substitute in this relation that A is equal to 1 minus volume of grains minus volume of water. Now, A is equal to 1 minus volume of soil grains. Now, the volume of soil grains we have found out to be is equivalent to gamma d by gamma s. So, 1 minus gamma d by gamma s minus the volume of water is W into gamma d by gamma W. So, W into gamma d by gamma W. We have also found out that basically A is equivalent to N into 1 minus SR. Now, for a particular soil, we all know that gamma S and gamma W are constants, because the specific gravity of soil solid is always constant. It is a material property. So, basically whether the soil is at any moisture content, whether the soil is at 1 point, whether the soil is at 1.9, whether the soil is 3% moisture content or 4.95% moisture content or 6.95 moisture content, wherever it is on this curve, this Proctor compaction curve, it does not matter. It is always said, since it is a material property, so gamma s and gamma w are always constants. So, all points representing states of soil for a given percentage of air voids are on one curve. And this is what we have to find out, because it is said are on one curve, because the percentage of air for a given porosity N and degree of saturation SR we have already found out. This is the percentage of air voids for a degree of saturation N and porosity SR. Now, this curve that basically we say this curve that we basically said about is said to be the points that connect the equal degree of saturation. So, basically these are the points, these all points represent states of soil for a given percentage of air voids are on a curve that basically connects equal degree of saturation. So, the equal degree of saturation curve is basically has a equation which is given by 1 minus gamma d by gamma s minus w into gamma d by gamma w is equal to constant, because the volume of air is considered to be constant in this case. So, all these points are on equal degree of saturation, that is saturation equal to constant, because the volume of air is not changing, and when the volume of air is not changing, that means basically the points are on the same degree of saturation curve. So, we can write this in this way, that gamma d by gamma w is actually equivalent to 1 minus A into gamma s divided by gamma s into w by gamma w. Now, this is a curve which basically is called as the saturation constants curve, or this has been already discussed in the slides. These curves basically may represent 100% saturation, may represent 90% saturation, and may represent 80% saturation as well. And it is always said that basically that 100% saturation line, this often called the zero air void line as well. The zero air void line can theoretically never intersect with the compaction curve. So, zero air void line corresponds to the void line of 100% saturation. So, let us see the curve. How does it look like? So, if this is a compaction curve, then the 0 air void line runs somewhere here, which basically has the equation of gamma d by gamma w equal to 1 minus a into gamma s by gamma s w plus gamma w. So, on this line the saturation is always constant. This is a 0 air void line. So, basically it is a 100% saturation line. Similarly, there may be 90% saturation line, there may be 80% saturation line, and accordingly, though in all those lines the saturation is said to be constant. Now, we will utilize this formula in our next problem. So, let us look to our next problem. Now, here also there are some results from a standard compaction test. Now we will see here, basically it is given in terms of mass of compacted soil and the water content or the moisture content. So, the mass of the soil in terms of grams is given as 1920.5, 2051.5, 2138.5, 2147.0, 2120.0 and 2081.5. The corresponding moisture content or water content at 11%, 12.1%, this is in percentage, 12.8%, 13.6%, 14.6% and 16.3%. Now, here the specific gravity of soil solids is equivalent to 2.68, that is, this is equivalent to GS, and the volume of compaction mold is equivalent to 1000 cc. So, here the first question is again asked to plot the compaction curve and find out the OMC and gamma D max, the optimum moisture content and the maximum dry density. Similarly, here in the second part it is asked that plot the 0%, 5%, 10% air void curves. Now, this is the thing that we have covered in the previous question. These are all the, this air void curves has the equation of gamma D by gamma W 1 minus A into gamma S by gamma S W plus gamma W. So, we are going to utilize this formula in the next problem. Now, this 0% curve means 0% air void curves means basically it is a 100% saturation line. That means basically here the saturation is 100%. So, the saturation is constant and it is equivalent to 100% saturation. Similarly, for 5% air voids it is equivalent to 95% saturation line, and for 10% air voids it is equivalent to 90% saturation line. It is also asked to find out that at gamma D max what is the value of E or the void ratio, the SR or the degree of saturation and air content. In the fourth part it is asked that if the natural moisture content in the field is 11.8%, then what will be the gamma D max if the soil is compacted with natural moisture content, that means with 11.8%. So, we are going to solve the first part. Now, the first part is pretty easy because the mass of the compacted soil is given. So, basically you have to only divide it by the volume. So, once you divide it by the volume, then basically you will get a figure, then basically you are supposed to get a figure, but basically remember that this is gamma, whatever mass of the compacted soil, when you divide it by volume, you are going to get the bulk density, you are not going to get the dry density. So, basically you have to convert the bulk density to the dry density. So, gamma bulk density is nothing but mass of compacted soil by volume of mold. So, here it will be, for the first case it will be 1920.5 divided by 1000. Now, similarly if you consider test 2, it will be 2051.5 by 12.1 by 1000. For test 3 it will be 2138.5 by 1000. All these numbers come from here, 1920.5, 2051.5, 2138.5, and it is given that the volume of the compaction mold is 1000 cc. So, we will consider test 3 right now. So, now you will have rho B, or the bulk density of the soil, as 2.1385 gram per cc. This is the unit that you are going to proceed, or there is one more unit which basically is equivalent to gram per cc, which is milligram per meter cube, megagram per meter cube. Now, as I have said that this is the bulk density of the soil. So, from the bulk density, now you have to find out what is the dry density, because the Proctor compaction curve is a plot of dry density versus the moisture content. So, the dry density now you can find out as rho D equivalent to rho B by 1 plus W. So, this will be equivalent to 2.1385 divided by 1 plus, now the corresponding moisture content is 12.8. So, 1 plus 12.8 by 100. So, this is equivalent to 1.896 gram per cc or megagram per meter cube. Now, this is done. Now, you have to plot the plot of water content versus the dry density. So, you will get a list of water contents, like let us say for the dry density from 11, let us start with the moisture content of 11, because 11 is the starting moisture content here. So, for 11 you will get the dry density as 1.730. Similarly, from 12.1 you will get 1.830. For 12.8 we have already got the moisture content as 1.896. This is in gram per cc. Similarly, for 13.6 this is 1.890, and like that. So, if you plot the Proctor compaction curve, it is going to show a curve like this, where this is going to be the gamma D and this is going to be the water content. This is going to be in percentage, while this is going to be in gram per cc or megagram per meter cube. Now, in the next question we are asked to plot the 0%, 5% and 10% air void curves. Now, using this 0%, 5% and 10% air void curves, we are going to utilize the formula that we have derived. Gamma D by gamma W is equal to 1 minus A into gamma S by gamma S into W plus gamma W. So, gamma D by gamma W is equal to GS into 1 minus A divided by 1 plus W into GS. It is similar to this formula, except that I have divided it by gamma W in every case, because if you divide it by gamma W in every case, then it comes out to be 1 minus A into gamma S by gamma W by gamma S by gamma W into W plus 1, which is equivalent to 1 minus A into GS by GS into W plus 1, and that is the same formula that I have written here. So this is, so A is basic corresponds to the percentage, as we have said that A is nothing but the volume of air. A is nothing but the volume of air, VA. So it is similar, it is already told that what is the volume of air to be. For 100% saturation line, the volume of air is going to be 0. So gamma D by gamma W, or basically you can write it in the format of rho D by rho W is equal to GS into 1 minus A into 1 plus WGS. This I will cut off, because gamma D by will proceed with gamma D by gamma W, or you can write it in the format of rho D by rho W, that is rho D by rho W is equivalent to GS by 1 minus A into 1 plus W into GS. Now for 0 AR void line, A is equivalent to 0. So we get rho D by rho W is equal to GS to 1 minus 0 by 1 plus W into GS, that is rho D is equal to GS into rho W by 1 plus W into GS. So this is the formula for 0 AR void curve. Now here the saturation is always 100%, and this is the equation for the 100% saturation line. So for different, so now for different water contents, let us say that basically if your water content is 11%, then in that case for 0 AR void line you will get rho D as GS is already said to be 2.68. So 2.68 into rho W is 11%. So 11 by 100 divided by 1 plus, sorry, this is not 11 by 100, this is rho W. Rho W is, if it is in gram per cc, because we are all writing in terms of gram per cc, so 2.68 into 1 to 1 plus 11 by 100 into 2.68. Now this comes out to be 2.68 into 1 divided by 1 plus 0.11 into 2.68, which comes out to be 1.96, sorry, 2.070 gram per cc or megagram per meter cube. Similarly, if it is like 3% air content, if it is like 12.8% moisture content, so also with another calculation like 12.8% is the W, GS is again given to be 2.68, then rho D in terms of gram per cc for 0 AR void line would be equivalent to 2.68 into 1, because the density of water is 1 gram per cc, divided by 1 plus 12.8 by 100 into 2.68, which is nothing but 2.68 into 1 by 1 plus 2.68 into 0.128, which is equivalent to, for the 12.8% is equal to 1.995 gram per cc or megagram per meter cube unit, suitable for you. So this is for the 0 air void line. Similarly, for 5% air void line, it will be equivalent to rho D by rho W is equal to GS into 1 minus 0.05, because the volume of air now is 5%. So it is equivalent to 1 minus 0.05, 1 plus W into GS. So GS into 0.95 into 1 plus WGS. Now we already know that rho D into GS into rho W 1 plus W into GS into 0.95. This term is actually equivalent to nothing. This term is equivalent to the 0 AR void line. So you can write it simply that 0 AR void line dry density unit in gram per cc multiplied by 0.95. So for, let us say for 12.8% water content, the third part, it will be equivalent to 1.995 rho D for 5% will be equivalent to 1.995 into 0.95 gram per cc or megagram per meter cube, whichever unit is again suitable for you. It will be equal to 1.896 megagram per meter cube. Now for the, similarly for 10%, it will be equivalent to rho D is equal to 0 AR void line dry density into 1 minus 0.10. So, it is equal to 0.90 into 0 AR void line dry density in gram per cc. So, for the same 12.8%, rho d 10% will be equivalent to 0.90 into 1.995 gram per cc or megagram per meter cube, which is equivalent to 1.796 gram per cc or megagram per meter cube. So, for every moisture content given here, that is for 0%, 5% and 10%, for 100% saturation, for 95% saturation, for 90% saturation, you have to plot the dry density, you have to plot the 0 air, you have to plot all these curves. Now, the water content is given to you, it varies from 11 to 16.3, corresponding to that the dry density has to be found out for all these cases, for 0% air void, for 5% air void and for 10% air void curves. Now, I have shown a sample calculation for 12.8%. So, for all these moisture contents, if you find out what are the air void curves, then they would look similar to this figure. This is our compaction curve. So, this is where the 0 air void line lies, as I have said that theoretically a 0 air void line can never touch a compaction curve. So, this is a 0 air void line, which basically is a line of 100% saturation. This is water content in percentage, while this is the dry density. Now, this is a 90% saturation line or basically the 10% air void line. And here lies the 95% saturation line or the 5% air void line. So, this is how the figure looks like, and all these points correspond to the water content that is given in the question, that is 11, 12.1, 12.8, 13.6, 14.6 and 16.3 respectively. Now, the third question that is asked is that what is at gamma d max, what is the value of E, SR and the air content. So, we are going to discuss that. Now, at moisture content, now let us say that at what is your gamma d max. The gamma d max is found out to be, the gamma d max or the optimum moisture content is found out to be 1.907. This is in gram per cc, but actually this is a unit weight. So, basically it will be 19.7 kilonewton per meter cube. So, since we have proceeded with gram per cc, so we will proceed with rho d max. So, this is equivalent to 1.907 gram per cc. The corresponding optimum moisture content is found out to be, or the OMC is found out to be 13%. Now, we know that rho d is actually equivalent to Gs by 1 plus E. So, Gs is already given to you as 2.68. So, this is equivalent to 2.68 by 1 plus E into 1.907. So, from here you can find out the value of E as 0.406. Similarly, if you go for the degree of saturation, that is volume of water divided by volume of voids. Now, how to find out the volume of voids? Now, for the volume of voids, you can assume that just like the previous class we have told that in the volume of voids you can assume the total volume to be 1 and then you can proceed. So, in this case if you assume the total volume to be 1, then how do you find out the volume of solids? Now, volume of solids you already know is nothing but Gs by the weight of the solids, Ws by the Gs. Now, Ws is again equivalent to Ms rho W into Gs. So, the mass of solids is 1.907, because at dry density we all know that it only consists of solids and air. So, the mass of the solids at that point, the mass of the soil mass at that point is equivalent to the mass of the solids, divided by 1 into GS is given as 2.68. So, the volume of solids comes out to be 0.711 meter cube. So, since the total volume is assumed to be 1, so the volume of voids is assumed to be 1 minus volume of solids, which basically is equal to 1 minus 0.711 meter cube, which basically is equivalent to 0.289 meter cube. Now, you can find out in this way, or basically there is one more easier way, but basically find out what is the bulk density first. So, bulk density is equivalent to gamma d into 1 plus W. Now, we already know that gamma d or rho d is actually for the maximum moisture content is actually 1.907 gram per cc, and the optimum moisture content is 13. So, 1.907 into 1 plus 13 by 100 is equivalent to, now gamma bulk can be written as GS plus AC by 1 plus E into gamma W, or rho bulk can be written as GS plus AC by 1 plus E into rho W. Now, rho bulk is already known to us, rho bulk is 1.907 into 1 plus 0.13, and this GS is 2.68. So, 2.68 plus S E is known at that point, which is we have calculated as 0.406. So, 0.406 1 plus 0.406, and density of water is known to us as 1 gram per cc. So, this is how you find out the value of degree of saturation. Now, the degree of saturation is known to us. Now, the third question, the last question that is asked to us is that what is the volume of the air content. Now, if you know what is the volume of voids, then obviously you can find out the volume of air content as well. Now, the volume of air content can be found out as the volume of air content is actually equivalent to volume of voids minus volume of water. Now, if you know the volume of water, as you have already calculated the volume of solids, if you know what is the volume of water, then basically from there you can find out what is the air content is, or basically you can find out from the degree of saturation itself, because degree of saturation is volume of water by volume of voids. So, the degree of saturation from here, if you find out, which basically comes out to be 85.8%. Here the degree of saturation comes out to be 85.8% or 0.858. So, 0.858 into volume of water by volume of voids. Now, volume of water is equal to 0.858 into volume of voids. So, volume of air is equal to volume of voids minus volume of water, basically is equal to volume of voids minus 0.858 into volume of voids. So, 1 minus 0.858 into volume of voids. Now, volume of voids you can find out from porosity itself, where porosity itself says that porosity, or basically from porosity itself, where porosity says that it is equivalent to Vb by V, where you assume the total volume of the soil to be 1. So, the porosity itself is the volume of voids. So, this can be found out as 1 minus 0.858 into 1 into N. Okay. So, if you know the value void ratio, from there you can find out the porosity from the relation E by 1 plus E. So, 1 minus 0.858. So, the E is given as 0.406. So, 0.406 into 1.406 into 1 minus 0.858. So, this is what is the volume of air, assuming that the total volume of the soil is equivalent to 1 meter cube or 1 centimeter cube, whatever, but unit volume of the soil is taken. So, we have discussed about how to plot the zero air void lines, how to plot the compaction curves, and basically we have also discussed that how basically you can how the theoretical zero air void line does not match with the compaction curve. Now, in the next part we are going to discuss a practical problem, or a general practical problem, that how are you going to apply the compaction in the field, because many real life situations actually require compaction. So, if basically a compaction curve is given to you, then basically how do you actually consider a compaction curve and what type of compaction you are going to use. So, the type of compaction that you have, so let us consider a compaction curve for a gravelly sand. A compaction for a gravelly sand is actually given to you, that basically consists of 24% gravel and 76% sand. Now this is to be used as a base course. A base course means a soil layer above the existing soil. Basically it is used in case of pavements, in case of highway embankments or pavements. So I am going to write that here, a soil layer above existing soil. So we have the compaction curve like this, where basically the maximum moisture content, this is 6% and this is 19.5%. So the maximum moisture content is somewhere here. This is the OMC, this is the water content in percentage, and this is the gamma D in gram per cc or kilonewton per meter cube, but here it is in kilonewton per meter cube. So this is the OMC, the optimum moisture content, and the corresponding gamma D max. Now the question is asked that basically what is the compaction criteria for the field? That means what type of compaction you are going to use, or which point you are going to use. Are you going to compact it on OMC, or basically are you going to compact it in the on the left side of OMC or on the right side of OMC? Now here you have to know that this left side and right side of OMC are very important, because in most of the earth structures, if you consider any earth structure like let us say embankment or any other case like embankments or basically let us say footings, in those cases basically they generally go for a 95% of maximum gamma D. This is a common practice that is mostly used. Now in other cases basically you can also go for dry of optimum. Now this level of compaction, this 95% of compaction, as you can see from the compaction curve, this 95% of compaction can be achieved in 2 points, one after the compaction while one after the OMC, while one before the OMC. Now if you consider the point which is before the OMC, this is called the dry side of optimum. So this is the 95% compaction. So this part is called the dry of optimum. This part. Well, this part is termed as the wet of optimum. So which 95% proctor compaction you are going to take, the dry of optimum or the wet of optimum? Now generally normal practice is that in most of the earth structure you are supposed to compact it at the dry of optimum, because in dry of optimum there are many advantages. Like this, the first advantage is being the permeability of the soil is pretty high here. While on the other hand, if you contact it on the west side of optimum, then the material may be ductile, but it is pretty, the permeability is pretty less. So that is why this weight of optimum is mostly used for clay liners, mostly for low permeability soils, like let us say swelling soils, for wasteland, covering for wasteland field, so that the leachate or the gas does not escape. In all those cases generally the weight of optimum side is used, while dry of optimum is mostly applied for earth structures. So in this cases basically, since you are supposed to, you are given a gravelly sand, gravelly sand. So the first important part is that basically first important thing that you are going to say that which side of compaction you are going to use. Now as I have said, there is a base course, so basically you are going to use on the dry side of optimum. So the first question is that on dry of optimum at 95% moisture content or 95% water content, we are going to use the compaction criteria. The second question is asked, recommend field compaction equipment that you, now what is they have asked, recommend field compaction equipment that would achieve the desired compaction. So they have asked about the field compaction equipment. Now what type of field compaction equipments are used? Now as you have already gone through the when you have gone through a compaction course, you have already known that there are many types of rollers like vibratory rollers, sheep rollers, then basically there are standard methods of compaction as well, like deep dynamic compactions. So which type of field compaction do you prefer? Now again you have to remember here that it is a gravelly sand. So, generally a sand type of thing is generally compacted by a vibratory roller. So, here also the since it is a sand type of thing and gravelly type of thing, it is a coarse grained soil. So, basically by adding water or basically by using tamping method will not work. So, here you going to use a vibratory roller. The final part that is asked is basically specify an appropriate quality control test. Now, a quality control test means that basically you are supposed to use a density test. So, basically the most important type of density test that basically you are going to use here, that basically will not that will require less labor, is basically the sand cone test. Now, a sand cone test has already been taught, so I am not going to cover the details here. So, this is how basically in a case study you are going to solve a problem. So, if a compaction curve is generally given to you and you are supposed to find out that what type of compaction you are going to offer, this is how your judgment should be, that basically depending on the type of soil first, whether it is a coarse grained soil or a fine grained soil, you are going to use the dry of optimum or the wet side of optimum, whether it is a clay liner or basically it is a arch structure, depending on that you are going to use a dry side of optimum or the wet side of optimum. Here it is basically it is a gravelly sand, so basically we have used the dry side of optimum here, and generally it is always specified to use the 95% compaction, 95% relative compaction. So, that is what I have also said here. And next you are going to use that whether it is depending on the gravelly sand, whether it's you are going to use a depending on whether it's a coarse grained soil or fine grained soil, you are going to use whether it's a vibratory type of compaction or basically it's a tamping method. So, basically since it's again a gravelly sand, we have used a vibratory roller here, and generally a quality control test that basically is always mostly a sand cone test, and sometimes different types of test, nuclear density meter is also done. So, today we have covered all the compaction part, and in the next class basically we are going to discuss the permeability part along with a little compaction and other case studies. Thank you.